A big problem humans are facing now is overusing of antibiotics. Antibiotic resistance is a global public health risk with high severity. Humans had created several superbugs which will cause diseases, and we don't have medicine to cure them now. In US, 70% of patients having sore throat receive antibiotics prescription, while only about 20 to 30% are likely to have a bacterial infection recommended for antibiotic treatment. Besides, results of survey in UK showed that 55% of GP felt under pressure, mainly from patients, to prescribe antibiotics. Nowadays, distinguishing bacteria and virus infection all need trained personnel and lab equipment. However, the process usually takes a long time and costs a lot of money. If we can stop the overusing of antibiotics, the days when a slight infection could kill you and your loved ones will be coming back. In order to prevent irreversible consequences caused by overusing of antibiotics, the iGEM team set up to develop specific, highly sensitive, rapid in vitro diagnostic device that will provide solid foundation for treatment. That is KC-AID+, Case13A controlled assay for infectious diseases. They believe that point-of-care IVD device, which is able to distinguish pathogens, will significantly contribute to revolution of antibiotics over prescription and respectively of antibiotics resistance crisis. You only need to put the patient's sample on the detector of the device, and the KC-AID+ will process to tell you whether you get bacterial or virus infection. It's cool and convenient, isn't it? So let us move to next section to know more about it. The main technique they use is CRISPR-Cas technique, and the team chose to use Cas13A was because of its unique ability. It can bind and cleave specific RNA rather than DNA targets. They can easily use those products for their detection mechanisms. They created new biobricks for expressing and purify the Cas13A protein used in their KC-AID+ system, and biobricks for investigation of degradation text with GFP. To express the core piece of their project, Cas13A, they cloned the protein sequenced in this set of biobricks for the version of Leptotrichia wideyi into a PSP1C3 backbone and fuse it with several elements of their pod collection. They first obtained a detectable amount of target RNA from a sample of E. coli cells, which they used as a dummy target. The extraction method should be efficient and not require the use of dangerous chemicals. Then they used RPA as an isothermal alternative to PCR. It's conducted without the need of thermal cycling, and therefore reduces the requirements and costs of the accompanying hardware significantly. Next step, they add Cas13A into reaction. Once Cas13A binds to target RNA, it starts to cut following RNAs, makes them fluorescent and detectable. Then the device filters the readout signals and records them. Those fluorescent substances are reacting in this region, which will be introduced later. The hardware on the right side consists of following three parts. First, the paper strip reaction unit. It is the place where to put patient's sample, and it consists of many layers to filter the signals. Second, the electrically controlled clock value, which is like a switch, is embedded in the sample processing unit. The sample processing unit features a temperature control unit for lysis and isothermal PCR. 2017 iGEM Munich team had done so many activities from 2016 to 2017. They attended as many different events as possible to make sure that they not only focused on the student and the scientific community, but also the general public. The iGEM team finally won a lot of prizes in the 2017 iGEM contest. I think the reason why they could do such an incredible thing is that their CASC AID Plus really gave us a better solution to the problem we are having now. The portable device really solved the problem they observed. The diagnosis doesn't need to be conducted only in several specific labs. We even can take it to everywhere we want to go. Moreover, it's extremely cheap. The materials of the device even cost under $15 US, and the diagnosis process is fast. In the video the team provided, it only took 5 minutes to analyze a sample. It is also precise. Fluorescence can be measured down to low concentrations. In my opinion, CASC AID Plus must be helpful to improve the medical environment in Africa. It fixes most of disadvantage we used to suffer from, but I think it still can be better. First, it could be more user-friendly. Normally, people don't have micropipette in their house. Even they do, they might not know how to use it properly. Second, if the device could tell people which bacteria or virus infected them, that will make CASC AID Plus more convenient and more powerful tool for diagnosis. This is my case study, hoping that I can become a member of iGEM NCKU-Tainan 2019. Thanks for your watching.